This is lesson 2 on functions and relations. So if we're looking at operations with functions, telling us here that the following properties apply to functions f and g, provided x is in the domain of f and g. So in other words, as long as x is part of the functions, in other words, as long as it's one of the points in the graph. The sum of f and g can be written as f plus g of x, or you can split it apart and write f of x plus f of g. It really means the same thing. You're adding the two functions. So if these functions are written like x squared plus 2x and this is x squared plus 3x, adding them together you get 2x squared plus 5x. And that's what's meant by this. You're just adding the two functions together. And this is just subtraction, or the difference. Here we're actually having, if you see this symbol fg of x, it really means you're multiplying the functions. Here you're dividing the functions. And because we're dividing by g of x, the denominator cannot be 0. So in this lesson we're going to consider the sum and difference of two functions, and in the next two lessons we'll consider the product and quotient of the functions. So scrolling down, we have this table of values here, and it's asking us to fill it in for adding the functions together and subtracting the functions. So if I write on my tablet here, we're adding the two together, so it tells us the values here. So this just becomes, if we add them together, it becomes negative 14. If we're subtracting, it's f minus g, so it's negative 7, take away negative 7, so it's just 0. And maybe we'll go down this column first and just add them together. So negative 5 plus negative 6 is negative 11. Negative 3, adding negative 5, we get negative 8. And so on. Negative 5, we get negative 2. You can see there's a pattern here, and this is 1, this is 4, so we're going up by 3s basically, and 10. Looking at the other function, we're subtracting. So negative 5, take away negative 6, really it's negative 5 plus 6, so we get 1. Negative 3, take away negative 5, means we've got 2. And you can see there's a pattern here also, the way it's set up. This will be 3, this will be 4, this will be 5, and this is 6, 7, and this is now 9 take away 1, which is 8. So basically you can now graph these things. You can graph x here against the value here. That would be your two coordinates. This would be your x coordinate, this would be like your y coordinate when you go to graph. So this point is negative 4, and up here at, way up here at, oh sorry, negative 14, forget that. We actually want to erase that because it's wrong. And negative 4, negative 14 is down here. Okay, so that's the first point. Then negative 3, negative 11. So negative 3, negative 11. So next point. Negative 2, negative 8. So negative 2, negative 8 is here. And you can see because it is a pattern, we're going up by the same amount here. We're going up by the same amount here. It ends up being a linear equation. You can just cheat by not even looking at your graph now, but by going up 3 and over 1. Up 3 and over 1, and so on, up 3 and over 1. We should find that the point 2, 4, and there we are, is on our table of values, 2, 4. We can do the same for this as well. We can graph x against f minus g of x as well. So this is giving us a straight line. I'm not sure I can draw a straight line with my free hand, but anyway, we'll give it a go. There we go, it's not too bad. Okay, so it will continue up in both directions. So I've scrolled down here to part D. Basically we've answered parts A and B and C. If you take a look at, you can easily sketch all those functions mentioned in part C. Part D here tells us that functions f and g on the previous page are actually these two functions here. And it's asking us to write expressions for these functions. So it means I've got to add them together. So in other words, f plus g of x is adding 2x plus 1, that's f of x, and we're adding it to the following, x minus 3, and x minus 3 is g of x. Now I have to get used to the amount of space here. Okay, so really what's this? 2x plus x is 3x, and 1 take away 3, negative 2. So that's the answer for that. That's as reduced as it can get. If we want f minus g, you just subtract these two equations and you get your answer. Let's see, using a graphing calculator for E to graph the functions from parts D and compare these graphs with the graphs in part C. Well, it should be identical because they've told us that these two are the functions. So on your graphing calculator, if you graph this, which is this equation here, and graph this, which is this here, you'll see that it's the same as the lines you would have graphed in the graph paper above. State the domains and range of these functions. Well, as you can see from the graphs on your either on your calculator or what you've drawn above, the domain is set of all real numbers because they're straight lines, and y is also a member of all real numbers, and for both of these functions. Determine the values of f plus g of 10. In other words, when x is 10, what is these two functions added together? Well, we can simply look at our summary here. We have f plus g simplified above as 3x minus 2. Or we could just do the whole thing again if you want and just fill in x being 10 in here and in here. But since we have it simplified, we can just say, okay, so that's 3 times 10 minus 2, which is 30 minus 2, or 28 is the answer. Subtracting, you do the same thing. If you've subtracted these two, we can do that right now. It's actually 2x plus 1 minus x minus 3. So this is f of x, this is g of x, and we're subtracting them. Simplifying that, we should get x plus 4. So if in this case, notice they're asking us to put x equal to negative 10. So plugging that in, we have negative 10 plus 4. That reduces to negative 6 for an answer. In this example, the sum and difference of two functions of degree 1 are also functions of degree 1. Can you find two functions of degree 1 whose sum or difference is not a function of degree 1? That's a bit wordy, isn't it? I'm just trying to think what that means. So while I do that, I'll just pause the video. Okay, so I've thought about this. What it's saying here is degree 1 just means the two functions we have are x. They have x, not x squared. So just an x to the 1, an x to the 1. So that's why they're both degree 1. Can we find two functions of degree 1 whose sum or difference is not a function of degree 1? So we have two functions, degree 1. So it's got to just have x to the 1, x to the 1 in it. But when we add them or subtract them, the function is not degree 1. I guess it could be degree 0. In other words, if we have a function such as f of x is x plus 6, and g of x is x minus 1. When we subtract these anyway, we'll certainly get an answer of 6. We'll get an answer of 7. So that's the sort of thing they're looking at. But don't worry too much about this question.